Okay, now we're going to talk about finding the volume of a solid rotation via shells. The first trick is to look at a single cylinder. Think of this as like a cardboard tube. It's hollow like a toilet paper tube. What is the area of this? If it's got a height of h and it's got a radius of r, then we can cut it in half and unroll, and we will get a long rectangle. A rectangle with a height of h, and now the width of the rectangle is going to be what previously had been the circumference, and therefore it is 2 pi r. And so the area of this is 2 pi r h. Yay! So now let's look at one with a slight bit of thickness to it. If we have something like this, where it's a little bit thick, so we have, what would this be? This is like we cut the top and bottom off of a thick coffee can, so it's got the thickness of the metal, which we are going to call dx. Dx means, well, not dx, delta x, change in x. Tiny little thickness, and it's got a height of h, and it's got a radius of r. Now the question is, which radius do we use? The inner radius, the outer radius? What I want to say is, if we unroll it, if we cut it and unroll it, just as we did before, we are more or less going to get the same rectangle, but now with a thickness. It's basically going to be h by 2 pi r with a little delta x thickness. And so the volume is going to be remarkably close to 2 pi r h delta x, whatever the thickness is, if the thickness is small. If the thickness is big, now the real question is, do I take the radius from the center to the inner wall or to the outer wall? That would make a difference, but I'm saying that this is so thin that they're basically the same radius. So now what we're going to talk about is, what happens if you had some function? I always draw the same function. Y equals f of x, and we want to rotate the length between a and b around the y-axis. What we can do, it's going to come around, it's going to go like this. Here's one advantage of me always drawing the same thing. I get pretty good at drawing the same thing. What we do is, we're going to slice this particular part of the area up into n different pieces, and any particular one of them is when we rotate just this little bit around the y-axis, it's going to make more or less one of these cylindrical shells. I'm going to write that out. Cylindrical shells. You know, we talk about how ogres and onions have layers. Well, this solid of rotation has layers, and this is one of the layers. And what is the volume of this? Well, basically, the thickness of it is what? B minus A over N, and the radius of it from there to there is basically, the x value that we have right there, which in this case is going to be, let's say, x is a plus I b minus a over n's, as always. And the height of it, well, okay, so it's not really a shell because it curves a little bit there. Hey, you know what I'm going to do? I'm going to say the height, but the height is basically given by the function. So the height is, so this is the radius, and the height is f of a plus I b minus a over n. And that's just one of these shells. If we add up all of them, then our volume is approximately the sum I equals 1 up to n of b minus a over n times, now wait a second. What I want is pi r squared, no, pi r squared h. No, 2 pi r h. That's right. 2 pi r h is the volume of a cylindrical shell, except that what we have is going to be I equals 1 up to n of 2 pi r is a plus I b minus a over n, and h is f of a plus I b minus a over n, times the delta x. And the delta x is this thickness times b minus a over n. And I know what you're saying. You're saying, well, that's only approximation. Well, we can make it exact with a limit as n goes to infinity. Hey, that is the volume. And I know what you're thinking. You're thinking, isn't there a nicer way of doing this? Well, if we call this the limit as n goes to infinity, and we bring this b minus a over n out front, sum I equals 1 up to n 2 pi a plus I b minus a over n f of a plus I b minus a over n, you might think, well, that doesn't help very much at all, unless you realize that this is the Riemann sum version of what? It's the integral from a to b of what? This thing in here gives me my function, if it's the function with a plus I b minus a over n in there. That appears twice. The function in this particular case is 2 pi, this is x, times f of x, and dx. In fact, this bit here, the thickness of it, that is your dx, but I should have gotten to that a long time ago, and it's a little bit late now. Maybe I'll talk about that in class. But do you see how this is basically the cylindrical shell? The cylindrical shell formula. Just like the disks methods, pi r squared, what is it? Pi f of x squared, where the radius was your function. The cylindrical shell formula, right? Because your cylindrical shell is, if the height is f of x and the radius is x, that's your volume. Your volume is 2 pi x f of x. And this is your formula, and this is a wonderful formula for finding volumes of solids of rotation around vertical axes. Let's do some problems.